All right, this is a video for Pre-Calc, Unit 1, Section 5, and this is about solving 3x3 linear systems. So we're going to classify systems of three variable equations as dependent, independent, consistent, or inconsistent. And we're going to learn how to actually solve these 3x3 linear systems algebraically, okay? So the first thing I want to do is talk about what we've gone over before. What we've had before is we've had two equations. So two equations, two variables, okay? And when you have this, you get two-dimensional graphs, and we want to see where do they intersect. So we want to find the intersection point. Okay. Now, the reason why we have two dimensions is because we have two variables. All right. Now, if we jump over and jump to three variables, okay, what we have here, so this is three equations, three variables, okay? And so these equations, they represent planes, okay? And we want to, again, just find the intersection, okay? So same idea of what we're doing here, just adding a dimension and adding a variable, okay, and adding a separate equation, okay. So what does this look like? Okay, over here, when you have an equation of three variables, that represents a plane. Okay, when you have two equations of three variables, then you have two options. Either you're going to have two planes that intersect and create a line here, okay. And you would have solutions to that equation, or you would have two planes that don't intersect, okay? Now, if you add in that third equation, then you add in a third plane, okay? And you're looking for a point of intersection, okay? And that's one solution, okay? And this is both of these are consistent, all right? If you get three equations where you have, they intersect and make a line like that, then you have a number of solutions, okay? And so then if you've got, say three planes where you've got two different lines, okay, then that means that you have no solutions, okay? And even if you had three intersecting planes, that would give you no solutions. The reason why is because, here at this point is a solution to all of those equations, okay? You would have an infinite number of solutions here that would make all of the equations true. But the problem is here you'd have different solutions that wouldn't make them all true. Okay, it would work for these two, but it wouldn't work for this one. Okay, and vice versa down here. And these are inconsistent. Okay. All right, now let's go ahead and move on to the next page. All right, so let's just go ahead and take a look at this example down here. Let's skip the one at the top of your page and just go to this one. And so what we want to do is we want to solve this. And the method that we want to use is elimination. Okay, so elimination, okay, and I'm going to number these equations as equation 1, equation 2, and equation 3, okay, and what I want to do is I want to use elimination to get, so here's what I want to write. I'm going to use elimination to get two new equations, okay, with two variables, okay, two variables. So what I'm going to do, what I first notice is that in this equation here, okay, I notice that these coefficients are opposite. All right, so I'm kind of looking at that one first. So I'm going to add equations 2 and 3, and that's going to give me equation 4, okay? And that will eliminate that y. So if I add 2 and 3 together, I'm going to get negative 4x plus 2y plus 4z is equal to negative 10. All right, I'm going to add that to 5x minus 2y minus 5z is equal to 14. I'm going to add these together, okay? Now, if I take negative 4x plus 5x, that's just going to give me an x. Okay, the 2y and negative 2y, those cancel to 0. All right, and then I get 4z minus 5z, which gives me a minus z. And then negative 10 plus 14 gives me positive 4. Okay, this is my new fourth equation. All right, and we're going to use that later. Okay. Now, the next thing I'm going to do is I'm going to multiply the top equation, number 1, by a positive 2 and add that to 2. So I see that I could easily get rid of this y right here. And the whole objective is we have to just kind of choose one variable to get rid of, okay? I have to think about, okay, I can get rid of the y here in this equation. Well, let's add these two equations together to get rid of the y. And so let me go ahead and do that. I'm going to multiply, I'm going to take 2 times equation 1 and add it to 2, all right? And that's going to give me the fifth equation, okay? So let's do that real quick. I'm going to do 2 times equation 1, which is negative x minus y plus 2z, and that's equal to negative 10. And then I'm going to write my second equation, which is negative 4x plus 2y plus 4z, and that's equal to negative 10 as well. Okay. As a result, okay, here's what we get. Okay. I'm going to get negative 2x, okay, distribute this 2 into here and distribute to all of it, minus 2y plus 4z is equal to negative 20. Okay, and then I'm going to put negative 4x down here, plus 2y, plus 4z, and that's equal to negative 10. Now, when I add these together, okay, I'm going to get negative 6x. This is going to go eliminate to 0. And then I get positive 8z, and that's going to equal negative 30. Okay, this is my fifth equation. Okay? So I'm going to write that up here. I'm going to write up my fifth equation, which is negative 6x plus 8z, and that's equal to negative 30. And the other one was that x minus z equals 4? Was that the fourth one? So remember, my fourth equation was x minus z is equal to positive 4, okay? So now, once you've created 2 new equations, okay, we've gotten rid of the y in both of them. Now, we just solve the 2 variable system like we did in the last unit, okay? So, let's go ahead and do this. Let's do, I'm going to take 8. Doesn't really matter which one you do, but I'm going to take 8 and multiply it by this one. So I'm going to multiply this equation by 8. And that's going to give me, let me rewrite the top one, negative 6x plus 8z is equal to negative 30. Okay, if I multiply this bottom one by 8, I'm going to get 8x minus 8z is equal to 32. All right. And so if I add these together, then I'm going to, 8z minus 8z goes away, okay? And then I'm going to get negative 6x plus 8x, which just gives me 2x. And that's going to give me positive 2 here, okay? Now I'm going to divide by 2 and divide by 2, and so what I end up getting is that x is equal to 1. Okay? So I've solved for one of the variables. Okay? But now I can use this variable now to go back and solve for z. I'm going to plug it into this fourth equation. Okay? So as a result, I'm going to get 1 minus z is equal to 4. Okay, plug 1 back in for x, solve for z, and I'm going to subtract 1 from both sides, and I get negative z is equal to negative 3. I'm sorry, positive 3. Divide by negative 1, divide by negative 1, and so we get that z is equal to negative 3. Okay, so x is equal to 1, z is equal to negative 3, and what I want to do is I want to go back and plug those in up here into one of these equations and solve for y. Doesn't matter which one we choose. Let's just choose one of them. I'll choose the top one because that's the easiest one. Okay, what do we have? X was 1, y or z was negative 3, right? Okay, so let's plug those in into the top. And so I'm going to get negative 1 minus y plus 2 times negative 3 is equal to negative 10. All I did was just plug these in for x and plug that in for z. Okay, and we're going to solve for y. So we end up getting negative 1 minus y minus 6 is equal to negative 10. Okay, if I add negative 1 and negative 6 together, I get negative 7. So negative y minus 7 is equal to negative 10. Going to add 7 to both sides, and so we get negative y is equal to negative 3. Divide by negative 1. Divide by negative 1, and we get that y is equal to positive 3. Okay, so the solution to our system, okay, is the coordinate point 1, 3, negative 3. Okay, and that is the point where all of those planes intersect. So it is tedious, it is kind of a pain, but at the same time it's, you know, just basically extending what we did in the last unit to another equation and another variable. Okay. All right, let's take a look at a couple of examples where, you know, we would, you know, solve this one. And so what I notice about this one is that I'm trying to figure out which one of these variables would I eliminate first. And what I notice is that here in equations 1 and 2, the coefficients are opposite in front of my x. And in equations 2 and 3, those are opposite as well. Okay? So I'm going to add equations 1 and 2 together. So I'm going to do that real quick, and I get that x plus 2y plus 4z is equal to 12. All right, and let's do negative x minus 3y minus 3z is equal to negative 16. Okay, so let's add these together, and I get x minus x, that goes away. Okay, I get negative y, and then I get, what do we get here? Positive z, and then negative is equal to negative 4. Okay, I'll call this my fourth equation. All right. Now let's add equations 2 and 3 together. All right, and so I'm going to do negative x minus 3y minus 3z is equal to negative 16. And then I've got x plus 4y plus 2z is equal to negative 2. Okay, add these together. Again, my x's cancel out. All right, and then we're going to get positive y, and then we're going to get negative z, and that's going to equal negative 18. All right, and this is equation 5. Okay, now let's take equation 4 and add it to equation 5 and see what we get. So we end up getting, I'm going to do negative y plus z is equal to negative 4. And then I'm going to get y minus z is equal to negative 18. Now if I add these together, all right, notice what happens. my y's cancel out, and my z's cancel out, and I just get 0 is equal to negative 22. Okay? Is that a true statement or a false statement?
False statement.
That's a false statement. So if this is false, what do we conclude about this?
Doesn't have a solution.
No solutions. Good. Okay? So if you're getting numbers, if you're able to solve these and get numbers, then you'll be able to get, you'll get solutions. But if you get a false statement, just like in the other one, if you got a false statement, then you don't get any solutions. Okay, now let's take a look over here. And what I notice on this example is that, here my coefficients are opposite. And so in 1 and 2, so I'll add 1 and 2 together to get rid of the y. But then I'm going to add equations 1 and 3 together because those are all opposite. You don't have to do 1 and 2 and 2 and 3. You can add whichever ones you want, okay? Tis the beauty of algebra. All right, so let's add 1 and 2 together. And that's going to give me negative 4x minus y minus 4z is equal to negative 11. Equation 2 is positive 2x plus y plus 6z, and that's equal to 21. Okay, if I add these together, then I'm going to get negative 4x plus 2 is negative 2x. Okay, negative y plus y, that gets eliminated. And then we are left with, what is that, negative 2z? Or no, positive 2z, plus 2z. And that's going to equal, what is that, positive 10? Okay, this is equation 4. Okay, we'll come back to that. All right, now let's take equations 1 and 3 and add them together. So I'm going to rewrite negative 4x minus y minus 4z is equal to negative 11. I'm going to take 5x plus y plus 3z, and that's equal to 6. Okay, add these together, and that's going to give me, what is that, just an x. The y's get eliminated. And then I'm going to get minus z, and that's going to give me negative 5. Okay? And this is equation 5. Okay? So then we've got, let's go ahead and add 4 and 5. So I've got negative 2x plus 2z is equal to 10. I've got x minus z is equal to negative 5. All right, so if I wanted to eliminate this and solve for a variable, I would go ahead and multiply this one by 2. All right, and so as a result, we would get negative 2x plus 2z is equal to 10. This gives me positive 2x minus 2z is equal to negative 10. Oh, so if I add those together, then I get that this gives me 0 plus 0 is equal to 0. So I get 0 equals 0. That's a true statement. Therefore, we have infinite solutions. Okay? So now let's take a look at this last question. Okay, it says a grocer makes a bags of trail mix that contain different amounts of almonds, raisins, and peanuts. Okay, and so we have all these different scenarios of cost associated with like whatever kind of trail mix you want. So if you wanted 2 pounds of almonds and 3 pounds of raisins and 1.5 pounds of peanuts, that would cost you $29.75. Okay, if you wanted 1 pound of each, it would cost you $13.50. And so on, okay? So what we want to do is we want to find the price of almonds, find the price of raisins, and find the price of peanuts. Standard 3-variable system problem. So let's take a look real quick, okay? So what I want to do, what I notice here first, and we want to get rid of one of the variables. And as I'm looking at this, you know, I would approach this to get rid of either the A's or the R's. Okay, and the reason why is because 2 of them have a coefficient of 1, and then the other one has 2. R's have, 2 of them have a coefficient of 3 and a coefficient of 1. So it doesn't really matter which one we use, but we just, it doesn't matter to me. Let's go ahead and let's just eliminate the A's for right now. So I'm going to get rid of the A's. So I'm going to multiply, I'm going to multiply, negative 1 by 2 and add it to 3. Okay? And then I'm going to take, multiply the third equation by negative 2 and add it to 1. Okay? So let's take a look. Let's do the red one first. I'm going to take negative 1 times A plus R plus P, and that's going to give me 1350. Okay, and I'm going to add that to A plus 3R plus 4P is equal to $29. So as a result, okay, I'm going to get negative A minus R minus P is equal to negative 13.50. Okay?
Wouldn't the A's just cancel out?
They will. Yeah, but I got to do, I'm just doing the steps, yeah. So I've got A plus 3R plus 4P is equal to 29. Okay? So if I add these together, okay, I'm going to get, the A's cancel out. Okay, and then I have negative R plus 3R gives me 2R. And then I have negative P plus 4P, which gives me 3P. And then that's going to give me, what do we get? Gives me 15.5. Okay, and that's my equation 4. Okay, we'll save that for later. All right. Okay, then I'm going to take 1 and 3, but I'm going to multiply the third equation by negative 2. So let's do, all right, what do we got? We got 2A plus 3R plus 1.5P, and that's equal to 29.75. Okay, and then I'm going to take negative 2 times, what was it, A plus 3R plus 4P.
It might be easier to just do that to the second one, since it's negative 2, and then it just puts negative 2 on all the variables, and then...
Yeah, that's what I'm doing. Yeah, that's what I got there.
Okay, yeah, I was just saying, multiply negative 2 to the second one instead of the third one. Just might be a little easier.
Oh...
But it's whatever.
Yeah, it doesn't really matter.
Yeah.
Yeah, it doesn't matter.
It's all good.
Yeah, it's all good. Yeah, you might be right, actually. Well, it's whatever. Okay, so A plus 3R plus 4P. And that's equal to $29. Okay, so as a result, okay, we get 2A plus 3R plus 1.5P is equal to 29.75. Okay, we get negative 2A. Minus 6R minus 8P, and that's going to give me, what's 29 times 2? 58? Yeah, negative 58. All right, so now add them together, and we're going to get, these are going to get eliminated. 3R minus 6R is going to give us negative 3R. 1.5 minus 8P, that's going to give me negative 6.5P. And then 58 minus 29, 29.75 is going to give me negative 28.25. Okay? And this is equation 5. All right. So now we've got equations 4 and equations 5, all right, and let's just write them down next to each other. So I've got 2R plus 3P is equal to 15.5. Here I've got negative 3R minus 6.5P is equal to negative 28.75. So now what I want to do is I want to solve for either R or P. I'm going to go ahead and eliminate my r because I've got these decimals here. I got this negative 6.5. I don't want to deal with that. So I'm going to multiply this equation by 3. And I'm going to multiply this equation by 2. Okay, and all I'm doing is just the opposites of those. So as a result, I'm going to get 6r plus 9p is equal to 15.5 times 3 is 46.5. Okay, and then I'm going to distribute my 2. I'm going to get negative 6r minus 13p, and then 28.75 times 2 is going to give me negative 57.5. All right, so now if I add these together, 6r minus 6r, that gets eliminated. Okay, 9p minus 13p is going to give me negative 4p. And then I'm just going to get 11 here. Yeah, 11. So now, negative 11. Okay, so if I divide by negative 4 and divide by negative 4, then p is going to equal 11 fourths. Now, 11 fourths is $2.75. So p is equal to $2.75. Okay, now I could take this value for p. I got to plug it back into one of these equations. I'll do the top equation. Doesn't really matter. But we'll do that to solve for r. So I've got 2r plus 3 times 2.75, and that's equal to 15.5. Okay, multiply that by 3. So we get 2r plus 8.25 is equal to 15.5. Subtract 8.25 from both sides. So we get 2r is equal to $7.25. Okay? And then divide by 2, so r is equal to $3.625. We'll just round that up to 63. Okay? All right, now what I'm going to do, I may have done something wrong, but that's the idea. Okay, now I'm going to plug these into just this second equation here. That seems to be the easiest, and solve for a. So I've got a plus r, which is $3.63, plus $2.75, and that's going to equal $13.50. Okay, so if I add $3.63 plus $2.75, that's going to give me $6.38. So A plus $6.38 is going to give me $13.50. Okay, so subtract that from both sides. All right. And then I've got, so $13.50. So A is equal to $7.12. Okay. And that's what we've got. So it is a long, long process. Okay, but it is reasonable, I think. So sorry it took me so long. It's just the algebras just involved. Okay, best way to get good at this is practicing. So let's get started on our work.